Hi, Mrs. Shredder.
Yep. What's up?
Nothing much.
One minute. We'll start. All right, here we go. Homework last night. Any questions?
Were we supposed to reduce the fraction? 'Cause
Always.
I didn't. Okay, I didn't just do it on some of them. So that means, did I get it wrong or?
Well, I'll do half point off.
Okay.
All right, here we go. 1 through 24. So number 1 is 3 3/4. Number 2, 4 2/5. Number 3, 6 2/9. Number 4, 6 3/8. Number 5 is just plain old 10. Number 6 is 4 5/12. Number 7 is 6 1/2. Number 8 is 2 1/3. Number 9 is 9. Number 10 is 24 2/3. Number 11 is 11 2/3. Number 12 is 7 5/6. Number 13 is 20 over 3. Number 14 is 33 over 5. Number 15 is 59 over 8. Number 16 is 102 over 11. Number 17 is 77 over 6. Number 18 is 81 over 5. Number 19 is 131 over 9. Number 20 is 163 over 7. Number 21 is 413 over 4. Number 22 is 1,295 over 6, big number. Number 23 is 907 over 12. Number 4 is 1,329 over 16. And that was it. Any questions? Nope. Okay. Make sure that that was put into the homework assignment as a picture. Once again, nothing this week except for lessons. We'll end on Friday on a chapter review. Come back from Thanksgiving break, do another review, and then take a chapter test. Here is your homework for tonight. All right, here we go. So today's class is called Comparing Fractions. Generally speaking, there's nothing new today. It's just I'm going to give you 2 fractions and ask you to compare them. So the question is, I'm going to give you 2 fractions and ask you which one is bigger, 5/11 or 3/11. All right, if it's that easy, then it's not much of a class. Obviously, there's going to be a bit more complication or a bit more complicated problems later on. But let's just look at how we would do this. If we had 5/11 and 3/11, and we were asked to compare them, in fact, ask which one is bigger, well, one way of thinking about this is to place both of these on a number line. No, I'm not saying we're going to put these on a number line. I'm just showing you a visual representation. 5/11ths and 3/11ths are somewhere between 0 and 1. We know that because the numerator, the top number, is smaller than the bottom number, the denominator. It's a proper fraction, so it's somewhere between 0 and 1. And if we were to put it on the number line, we look at the denominator to tell us how many parts that we need to separate this into. I need to separate this number line into 11 parts, so there's my 11 parts. And then we can label this. This would be 0/11ths, this would be 1/11ths, 2/11ths, so forth and so on, all the way up to 1 or 11/11ths. So where would 5 and 3/11ths? Well, we simply count 1, 2, 3. Here's would be 3/11ths. There's 10/11ths, and 5/11ths would be 2 more. So it's pretty easy to visually see that 5/11ths is bigger than 3/11ths. Now, I don't think any of you would need to put this on a number line in order to figure out which one is bigger, right? So today, that's what we're going to be doing. I'm going to give you 2 fractions and just ask which one is bigger. It's one of 2 games we'll be playing. Really sounds simple. Obviously, when we have common denominators, it's a very simple thing. Why? Because the numerator 5 is bigger than the numerator of the second fraction. But that's only true if we have common denominators. You can't make a determination of which fraction is larger based solely on the numerators, because sometimes we won't have common denominators. So therefore, we need to look, the big but here is we need to look at the more complicated one, is when we don't have common denominators. Once again, you can't just assume that since 7 is bigger than 4, that 7/10 is bigger than 4/6. We have to make sure that is in fact true. So the process, anybody know what we're going to do here?
Find the least common multiple of the denominators.
Right. Basically, we're going to get common denominators, make equivalent fractions. So that's what we're going to do. So all the technique here involves is finding the common denominator, that is the least common multiple, change both fractions into that common denominator. In other words, get equivalent fractions for both. And then, and only then, when we have common denominators, can we look at the numerators and compare the 2 numbers. Okay, so technically that's nothing new. We've done this before. In fact, this was homework 2 nights ago. Get common denominators, make equivalent fractions. So let's do that. Once again, it is an easy process because we've already learned it. It's just getting common denominators. So in order to do this, we look at just the denominators, 6 and 10. We might do this in our head. We may do this on scratch paper. We find the least common multiple of 6 and 10. So 6, 12, 18, 24, 30. We continue that process until we define a common denominator. We just did. It's 30. And then comes the more the work of this problem, which is we need to make equivalent fractions. So my recommendation on your scratch paper, you write the first fraction and you write what you're trying to turn it. I'm trying to turn it into something over 30. So we would multiply the top and the bottom, the numerator and the denominator, by 5. 5 times 6 is 30. 4 times 5 is 20. So that's what 4/6 is. It's now 20/30ths. We do the same thing with 7/10. What times 10 is 30? That would be 3. So we multiply the numerator and the denominator by 3, and we get 21/30. Now we can look at, in blue here, we can look at just the numerators. So we have a numerator of 20. We have a numerator of 21. The bigger one is 21. Now look back at what you created it from. I created that from 7/10. So yes, 7/10 is bigger than 4/6. Now that is a coincidence that it also matches which numerator is large. That will not always be the case. There will be times when the smaller numerator is actually part of the larger fraction. We'll see that eventually. Okay? Questions on what I just did?
Yeah, I have a question.
I have a question.
Go ahead.
Wait, who asked first?
I had a question. So if you can do for a few of them, if it's easy enough without doing all of this, could you just figure it out?
Well, how would you do it without doing this?
I don't know. I just kind of look at the numbers and then just do it in my head.
Well, are you doing this? Are you making common denominators?
Yeah.
Well, I mean, obviously, if you can do it in your head, but I will caution you, as long as you're getting common denominators, well, that's the technique. But if you are doing the whole thing in your head and you make a simple mistake and you put the wrong answer down on a test or quiz, I take away all the points. So I would highly encourage you to at least show me that you're getting common denominators, not just circle which one is bigger. All right.
Okay.
Now, if there are common denominators, and I'm flipping to the homework, if there are common denominators, I'm looking. I don't see a single one where there are common denominators. But if there were, then clearly there would be no work. But for all the ones, I mean, you can open your book and look at the homework. Most of these are very challenging numbers to work with.
Yeah.
All right.
I have a question.
Go ahead.
So, can't you just simplify like 20/30ths by 2/3?
Well, okay, you can, but well, which one's bigger, 2/3 or 7/10? You'd still have to get common denominators, and the common denominator would still be 30, correct?
Correct.
Now, if by chance that this was, I don't know, let's say 1/3, and then yeah, that would be easiest to do. Change this to 2/3 and then make that comparison. So I don't know if there are any examples like that for homework, but yep, you could absolutely do that. Any other questions? Okay, let's do one. Write these two down, please, on a sheet of paper. 5, 6, and 7/8. 5, 6, and 7/8. Okay. So we need to find a common denominator between 6 and 8. Some of you can do this in your head. Others of you will need to write down all the multiples of 6 and 8. Remember, always start with the smaller. 6, 12, 18, 24. Oh, 24. Now, as I'm doing this, when I count the multiples of 6, I'm thinking of the multiples of 8 when I'm doing this. Is 12 a multiple of 8? No. Is 18 a multiple of 8? Is 24? Oh, yeah, 24 is a multiple of 8. So you don't necessarily have to write down the second list of multiples for the second number if you can do both of these at the same time. Now, really what you're doing is 6 at one time, but then you're taking a pause and considering is the answer 12 a multiple of 8? Is the answer 18 a multiple of 8? That's generally how I will do it, but I will still physically write the numbers down just so that I can visually see them. I think it aids in the process. All right, so we need to turn this both fractions into something over 24. What times 6 is 24?
4.
Okay,
4.
so we multiply top and bottom by 4. We get 20 24ths. We do the same thing with 7 over 8. What times 8 is 24?
3.
Then we multiply top and bottom by 3. We get 21 over 24ths. And we can once again figure out that which one is the larger. 21. I'm just looking at the numerators now. 21. And many people, and I debate whether I should make this always my second example, many people erroneously conclude that, wait, 7 is bigger than 5, so therefore it must be the larger. That's not always the case. Not always the case. Questions on this one? Okay. 2 more. Write these two down. 4/9 and 5/12. 4/9 and 5/12. All right, we need a common denominator between 9 and 12. 9 and 12. I'm going to count by 9. I'm thinking about 12s. 9, 18, 27. Neither 18. 18 is not a multiple of 12. 27 is not a multiple of 12. 36 is a multiple of 12. Okay. If you needed to continue and physically write down both lists, you would absolutely see that, hey, we've got common denominators. Okay, so 36 is the magic number we're trying to turn both into. What times 9 is 36?
4.
Okay, top and bottom by 4, we get 16 over 36. 5/12, what times 12 is 36?
3.
Top and bottom by 3. And now we see that we have common denominators. We now can compare our numerators, the top fraction, or the top number of the fractions, 16 and 15. 16 is bigger than 15. 16/36 belong to 4/9, so there's an example of where 4 is smaller than 5, but 4/9 ends up being the larger of the two fractions. So once again, don't always assume that the largest numerator is the largest fraction. Right? You have to get common denominators. Questions? Okay. All right, do these two all by yourself. 2/5 and 1/4. 2/5 and 1/4. Do these by yourself. I'll give you a 30-second head start, and then I'll walk you through it.
Can I answer?
Well, let me walk. There might be some other people that need some help, so I'll let you make the final answer. All right, here we go. 2/5 and 1/4. So I need to find the least common multiple of the denominators, 5 and 4. So let's see, 4, 8, 12, 16, 20. Oh, it's got to be 20, right? It's got to be 20. Got to be 20. All right, so I need to turn 2/5 and 1/4. 5 times 4 is 20. 2 times 4 is 8, so I get 8/20ths. And for 1/4, 4 times 5 is 20. Therefore, whoever asked what is the larger of the two fractions?
5th.
2/5 ends up being. Now, how come I didn't say 8/20ths is the largest fraction? Technically, that's right. But remember, they're asking which of the original two were the largest fraction. So even though 8/20ths is technically the right answer, right, we're going to go back to what 8/20ths originally was, which was 2/5. Okay, so 2/5 is the larger of the two fractions. Questions? Okay. Once again, get these started. I'll give you a 20-second head start this time.
Can I get the answer?
Well, after the time's up, sure.
Yes.
Okay, what's the answer? What's the answer?
3/10 is greater than 7/25.
All right, let's see if that's true or not. 25 and 10, we count by 10, 10, 20. No, it's 25, 25, 50. So it looks like 50 would be the first multiple. So 50 would be the common denominator. We write the first one. Let's see, 25 times 2 would be 50. 2 times 7 is 14, so I get 14/50ths. On 3/10, 5 times 10 is 50. So we would do top and bottom times by 5. 5 times 3 is 15. So she is correct. It is, in fact, 3/10 is larger because 15 is bigger than 14. All right. Questions? Anyone? Okay, cool. All right. So we're going to play a couple games. Let's play a new game. So this one's a bit more challenging. So they're asking you to look at two fractions and then tell me at least one fraction that is between these two fractions. Tell me one fraction that is between these two fractions. For those of you that were saying, oh, I can do this in my head, well, here's one you're not going to be able to do in your head. Tell me one fraction that's between these two fractions. Well, that's kind of a challenging thing, right? But
what you could do, sorry, Tron, sorry,
go ahead,
did I
go ahead.
Okay, what you could do is that you can do a common multiple and then do a number line of that and then find any fraction that's between those two.
And that's what we're going to do. We're not going to actually make a number line, but yes, that's exactly what we're going to do. What we are going to do is we're going to make common denominators, and then once we have that, you'll be able to see how easy it is to find a fraction between the two. All right. So if you think about the number line, since she brought it up, when we have common denominators, it's very easy to see a fraction between the two. What's between 3/11ths and 5/11ths? 4/11ths, right? So
4/11.
easy to do when you have common denominators. So that's our technique. No, you don't have to make a number line. So here's how it's done: 3/4 and 3/5. Same thing we just did before. We're going to make common denominators. 4, 8, 12, 16, 20. So it looks like 20 is the common denominator because 5 also goes into 20. So we make both these into common denominators. Both fractions are, so we make two equivalent fractions from the given two fractions. 4 times 5 is 20. 5 times 3 is 15. So we get 15/20ths. And 3/5, let's see, 5 times 4 is 20. So top and bottom by 4, 3 times 4 is 12. Now I have two fractions. Now here's what you have to do in your head, or if you need a number line, you can put these on a number line. It would take a long time to put these on a number line. The two fractions numerators are 12 and 15. So if these were on a number line, 12/20ths would come first and then 15/20ths. But there would be two fractions between these two. There would be 13/20ths and 14/20ths. So it says name a fraction, a single one, so you have two options here, either 13/20ths or 14/20ths. Either one is fine. These are questions 13 through 18. I'm sorry, 13 through 22. These are all the same basic problem. They'll give you two fractions and ask you to name one fraction. Now, I gave you two, one fraction between the two fractions. Questions on what I just did?
Homework's only 1 to 18 though, right? 1 through 18?
Agreed,
Well-
but you know, for those of you looking at, you know, if you needed extra practice, you could do the other ones as well.
Okay.
All right, so let's do these two. Give me a fraction between 7/12ths and 8/15ths. And like I said, you can't just look at these two and, you know, immediately figure this one out. This one takes some work. Sometimes intuitively, you can always pick which fraction is larger, but to figure out a fraction between the two, yeah, you're gonna have to do this work. So let's see, we got 12 and 15, 12 and 15. Let's see, 12, 24, 36, 48, 60. And if we count by 15s, 15, 30, 45, oh yeah, 60. 60 is the common denominator. Once again, all of these skills that we've done for the last at least 3 days are all based upon your ability to look at two numbers and find the least common multiple in order to make common denominators. So it is a skill. The more of these you do, the better you will get at that. All right, one fraction at a time, 7/12ths. We need to turn it to something over 60. What times 12 is 60?
What was the question again?
What times
Sorry.
12 is 60?
5?
Yep. Top and bottom by 5. 5 times 7 is 35. 35 over 60. For those of you that need help, remember you can always have a multiplication table on any quiz or test that I give you. So that could speed the process up a little bit. Let's see, we've got to do the same thing to the second fraction. What times 15 is 60? I will say for those of you that are paying attention, check this out. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. You can get that if you write down the multiples. So we need to multiply top and bottom by 4. 8 times 4 is 32, so we get 32 over 60. Notice there are what? Two numbers between 32 and 35, 33 and 34. So pick whichever one you like, 33 over 60 or 4 over 60, 34 over 60. Any of those would make sense. Okay, questions on what I just did? Okay. All right, here are two. I'm going to give you a 30-second head start. Find at least one fraction between those two fractions. Give you a 30-second head start. Find one fraction between those. Find common denominators, get equivalent fractions, and then pick one number between the two numerators.
I have an answer.
All right, let's see if your answer matches my answer. All right, here we go. We got an 8 and 10, an 8 and 10. That one's pretty simple. If you count by 8s, remember any multiple of 10 ends in a 0. So we simply need to count by 8 until we get to something that ends in a 0. 8, 16, 24, 32, 40. Hey, that wasn't too bad, 40. So I need to make two fractions whose denominators end in 40, or let's see, that would be 5 times 8. And once again, I'll just point out 8 times 1, this is times 1, times 2, times 3, times 4, times 5. So if you write this down right here, you can get the multiple pretty quickly. 8 times 5 is 40, and 5 times 5 is 25. And on the second one, 10 times 1, 2, 3, 4, 10 times 4 is 40. And 4 times 7 is 28. Therefore, Thea, what was your guess? think it was Veda that, wasn't it?
You're muted.
Thank you. It could either be 2640 or 2740.
And that's what I got. So 26 or 40. Now I got a picture of a butt here, so there must be a butt. Anyone know what the problem might be with this process? We will run into one problem. Nobody? All right, I will show you the butt. So the last one is the more challenging one. So what would happen if I gave you that? Pick a fraction between them. We got a problem because we have common denominators and there's no number between, or no whole number between 5 and 6. Anybody have any ideas?
You could just do a common multiple and then like times, I don't know, on top of my head.
So what
Do
would
what
be
we
the
just
suggestion?
did. Do what we just did and then see if there's any number between them.
So she's right. I just want to point out that the previous procedure was to get a common denominator. We already have a common denominator. It's 8. The issue is that there are no whole numbers between 5 and 6. So her suggestion is we'll find another multiple. In other words, instead of using 8, let's use
16.
Let's use 16, right? So the easiest thing is just choose the next multiple of the common denominator. In other words, count by 8, 8, 16. So we're going to choose 16 and make that our new common denominator. Even though it's not going to be the least common multiple, it's going to be a common denominator. So we're going to choose the very next one. Now you could choose any of them. I mean, I could choose 40 if I wanted to, and I would get to a correct answer, by the way. But the easiest method is to choose the next multiple of the common denominator, in this case 8, so we will choose 16. So then the process is the same as we did before. I turn 5/8 into something over 16. In other words, I multiply the numerator and the denominator by 2, so we get 10 sixteenths. And then I take 6/8, the same thing, and multiply top and bottom, numerator, denominator by 2, and we get 12 sixteenths. And you can see that we have one number between them, and it will be 11 sixteenths. Okay? So that is how we handle these tricky ones. By the way, we could have turned this, and it would be a correct answer, we could have turned them both into something over 40. Let's see, that would be 8 times 5 is 40, and that would, times 5 on the top, that would give me a 25 over 40. And on this one, we'd be multiplying by 5, top and bottom. And that would give us, what, 30 over 40. Now there's lots of numbers, 26, 27, 28, 29 over 40. All of those would be numbers. So technically, you have lots of options here, but the easiest one is to choose the very next multiple, because then each time you're simply going to be multiplying by 2. So you can kind of see a pattern there that will form. All right. So write these two down and simply tell me a fraction between 3/4 or 3/7 and 4/7.
Um, 1/2.
Yeah. They're not supposed to be yelling out answers.
Oh, sorry.
All right. So let's take my advice here. This next multiple of 7 would be 14. So we multiply top and bottom by 2, and it will always be by 2 in this particular process. So we get 6/14. We do the same thing to 4/7, multiply top and bottom by 2. That will give us 8/14. And the number between 6 and 8 is 7. So we get 7/14, which is 1/2. So the question is, do you need to reduce? And we're going to say always, always reduce from now on. Always reduce from now on. All right, questions on anything that we did? All right, Jasmine, we good on this? Jaden, we good on this? Okay, she gave me a thumbs up. Caden, we good? Is the dog good? Not the dog. That's your thumb, not the dog's thumb. Bo, we good?
Yep.
And Vay, we good?
Yeah.
All
That
right.
dog was so cute. I'm gonna
Anyone
steal
else?
that dog.
Anyone else that's not live, if you have any issues, then you're going to send me a chat or an email, and I'd be happy to help you out. For the rest of you, this is your homework. Go ahead and get started on it. I'll stay next to my computer for the next 10, 15 minutes. So if you run into any problems, you can just send me a quick chat, and I'll give you some help. So get started on your homework, and you guys have a wonderful rest of your Tuesday. See you later.